This is a quick demonstration of setting up the Acuity AR700 series of laser, and in this case we have the AR700-1, and we've got it on a little stand. As you can see, the stand's not the best. It's got a surface finish, so if you're going to try and calibrate using the Acuity demo software, definitely use a granite block or granite stage to make this much more accurate. But we're just going to do this real quickly. We've got here you can see in our demo software, we've got it set up for AR700 model. We're coming out of the COM3, and we have selected the -1 sensor, which is the model we have. And here you can see we've got, and typically you're going to hit initialize, which will turn the laser on. And I've let this warmed up for about 10 to 15 minutes, and you can see we're pretty stable out here on that range. And if we did a quick relative or 0, and I put a little ceramic plate there trying to make it a little more accurate, and I've got a 1/2 inch block, and you can see I'm within about 8/10. Not too bad for just starting out, but let's see if we can do a quick linearization to make it a little bit better. And let me try and get this stable here. So typically we would come into the linearized sensor. I do have the background light illumination turned on, which will help modulate the laser. So let's try to linearize it real quick. Here we're going to aim it at what we call our home position, and so that's going to take that point right there, and then we're going to put in the 1/2 inch gauge block, and we're going to type that in to the field, and then we're going to hit measure gauge block, and it gives us our thousandths of an inch per count. We're going to hit done, and so now we're going to take the block off. We're going to hit relative, then we're going to go absolute, and so here you can see without the best fixturing, you know, we got clamps and everything else, we have corrected that laser very easily to within our spec of ±3/10 without any problem. And so now, typically, as an example, we're measuring 526, and if you were to block the beam of the laser, so the beam gets lost, doesn't know where it's at, and now we're coming back to within about 20-30 millionths. So this is a real good way to show how repeatable the laser is. You know, it's lost, it doesn't know where it's at, and now coming back, very, very, very repeatable. And that's the key to the laser. Once you have it set up and linearized, with this example, a simple 2-point calibration, we can come in and make some very accurate measurements.